Okay, so some more fun stuff here. Rules, right? We're going to learn rules. It's how to simplify radicals. Yeah, rules. You're going to have to learn them. You get to know them. I know we had to do this sort of thing before, so have fun. Radical expressions. A mathematical expression that contains a radical. So, and I'm just talking some lame term from the 80s. Radical symbol, that's this thing here, right? Radical symbol. This. Now we can have more than just square roots, by the way. The index right here, degree of the root. If there's no number, assume it's 2. So assume I want square root. We can have cubed roots. For instance, like the cube root of 8. Let me write that out for you so you can see that happen. So I can have the cubed root of 8. That means what number times itself 3 times makes 8? In other words, it's 2, because 2 times 2 times 2 is 8. We can have 4th roots, 5th roots, billionth roots, whatever. If there's nothing written there, though, assume it is square root. Also, we have here radicand. That's the expression under the radical symbol. The radicand, right? Radicand, like you radicand do this. Radicand. Okay, some rules here. A radical expression in simplest radical form when each of the following has been met. So is in simplest form. No radicands have perfect squares other than 1. No radicands, remember that's the term underneath, have fractions. No radicals in the denominator of a fraction. So in other words, you can't have something like this, right? No, that is not simplest form. You can't have something like this. Not simplest form. Right, okay, so make sure... Oh, you can't have something like this. Not simplest form. Okay? So, simplest radical form. I know it's stated as no's, but that's what it really is. And we're going to do lots of these to practice for a couple of days. And I'm a real stickler on this. You know what I'm like. You've been in here long enough by now. Okay, we do have the multiplication property of square roots. For any a and b, right? Where a is greater than 0 and b is greater than 0. It's kind of important, right? Because we're not doing imaginary numbers yet. A times b is the square root of a times the square root of b. For example, if I had 3 times 2, all under the radical symbol, that is the square root of 3 times the square root of 2. It's kind of like, if you remember that technically square root means the half to the half power, that's really why this works. So, and we learned all those rules before. Where this is useful is if I asked for the square root of 18. Technically, that's the square root of 9 times the square root of 2, which is the square root of 9, times the square root of 2, which is 3 times the square root of 2. That'd be simplest form, by the way. That's what we're looking for here. Division property of square roots. For all a, we had a multiplication property, right? So we're going to have a division property. For all a and b, where a is greater than 0 and b is greater than 0, because again, we're not doing that whole imaginary number thing. A over b, all under the square root, can be broken up. For example, if I gave you the square root of, let's say 9 over 4, that would be the square root of 9 over the square root of 4, or 3 over 2. Got it? There you go. Rationalizing the denominator. This is multiplying the numerator and denominator by a well-chosen denominator to remove the radicals from the denominator. Mess that up, but you can read it. So here's what I'm really doing. If I had 2 over the square root of 3, that is not an acceptable form if I said I wanted it in standard form, right? Or simplified form. But what I can do, well-chosen 1. Haha, watch this. Square root of 3 over the square root of 3. I assume you'd agree with me that is the number 1, right? Anything divided by itself that's not 0 is 1. Well, watch this. This becomes 2 times the square root of 3 over the square root of 3 times the square root of 3. There we go. Which means I can have 2 times the square root of 3 over the square root of 3 times 3. That's that multiplication rule we just learned. Or, there we go, we have 2 times the square root of 3 over the square root of 9, or 2 times the square root of 3 over 3. Now I know you're thinking that is way worse looking than this, but it doesn't matter. This is the simplified form because I multiplied the top and the bottom by a well-chosen 1. This is the number 1 technically, right? A well-chosen 1 to get rid of the radical in the denominator. That's what's called rationalizing the denominator. You made it rational. It's no longer an irrational number. Now it's a rational number.